My name is Asger Sørensen. I'm a professor at the Department of Marine Technology at NTNU, but I'm also director for a Center of Excellence called Autonomous Marine Operations and Systems, AMOS. AMOS is a center of excellence where we are addressing fundamental research and we are also working interdisciplinary between marine technology, control engineering and marine biology. We have three big programs. One is on technology for mapping and monitoring the oceans. The second project is on marine robotic platforms, and the third is more classical on maximized operability and safety of ships and ocean structures. And based on that, we are doing fundamental research on marine structures, on marine hydrodynamics, control engineering, artificial intelligence, marine biology, and to put this into a context for almost all applications into the oceans. So we are working with maritime. One of the hot topics there are autonomous ships. Another hot topic is how could we make the ship fleet greener. You could say shipping is probably the most efficient way to do logistics around the world. But still, shipping is providing a lot of emissions of CO2 and other gases. So the International Maritime Organization by UN decided that by 2050 we should reduce the emissions from shipping by 50%. It may not look that ambitious, but think about now that you are going actually to transport from, for instance, from Europe to the Americas. And how should we replace, for instance, the traditional fuel like diesels by new type of fuel? And we also know that the ships are going to live for 20 to 30 years. So that means that ship we are going now to launch today needs to meet these requirements. And also by 2050, the ship at that time should have emission in the order of 1/3 as it is today. So this is a really huge challenge, and I think the way we are approaching it is from many fronts. One is on new types of fuels. Another way to deal with that is also related to digitalizations. And we see that just also for the shipping, is that one reason for why ships are going fast is can be, of course, because the goods you're transporting should be in place, but a lot of these goods you are transporting could definitely go slower. So another reason then for go fast is that people are on board, they get bored, and then they need to go home, of course. And so what we see is that by introducing autonomous ships or unmanned ships, we can set up completely new transport patterns where you actually can go slower and also drive or in a way float with the stream, and you don't need to fight that hard with the environment. We also have an explosion in data. So that is another huge challenge. How are we going to share data? How are we going to interpret the data? How could we, in a way, standardize data from different sources, from different researchers, in order to have the complete pictures? We have to combine data scientists with ecosystem experts, technology experts. And that is also creating you could say, a technology push, but also, I would say, creating completely new knowledge for governance. Because how should we balance all this interest? What is the correct information for decision making? When it's safe to, in a way, install, for instance, a fish farm installation, and how do we make sure that this fish farm installation is not harming the natural upwelling which is taking place? Should we install a fish farm in this fjord, or should we move out, and how to avoid conflicting interest? And I think that is also, you could say, both a technology push, but also a more interdisciplinary understanding about the importance of the complete picture, where you actually have to have both technology insight, you need to know the social science, the ecosystems, and based on that we have to do proper, I would say, management of the oceans. I think one of the most critical elements to be successful in the business is actually that you have a demanding customer. And also you have a customer that is willing to take the risk which is involved to take a new product. And I think from my point of view, we could be even, I would say, more brave from the public and from the governmental institutions also to piloting new technology. So if, for instance, we are going to do new mapping of the oceans to have a better understanding of that for management purposes, we should definitely also, as a part of that, test, demonstrate, and take new technology into use, both for the, I would say, for the benefit of the existing industry, but also for the possibility to take new technology into use and new players into use. And here I think we in Norway should be even better to use, I would call public purchase in any sector to create this shift in technology in order to meet, I would say, the global challenges, but also to create business opportunities for the industry. Because there is no doubt that it's a huge step from the research table to very early demonstrators, and also to have this into, I would say, real use, and that you could do a proper commercialization. At NTNU, we are providing knowledge just also for the sake of knowledge. But I will say that we are providing even more for, I would say, what we call impact. And one of the impacts we are providing is into the industry for value creations. And the majority of the research results we are doing is feeding directly into the existing industry. But then we see that the existing industry will time to time not be able to take what we call a disruptive change. And in order to take this disruptive change, then we born the new industry. And from Almos, we have so far born, it's launched 8 companies. And they are typically starting to work where there doesn't exist any industry as such, and they are going into a completely, I would say, new approach and taking in the new business opportunities. So I used to say that the only thing that is constant, and that is the change. That is both for existing industry, but as said, time to time, you also have to feed into this with something completely new possibilities. And that has always happened. And I think from the research environment, we should always be aware of that the new knowledge can actually create completely new possibilities, and we should take them.
My name is Ove Hagesæter, and I'm the CEO of GC Ocean Technology, which is an industry cluster with more than 130 partners and members. We are a kind of an innovation ecosystem where small and large companies have an arena to meet and collaborate. And at the same time, it's also an arena where collaboration between institutes and academia and the industry is fostered. And very important, it's also a place where capital is linked to great ideas, innovation projects, and growth companies. Now, this is important because it helps to unleash a great potential of value creation among the companies in this ecosystem. Well, the latest tech trends in the maritime field is a global shift towards a more sustainable ocean economy, but also a shift towards ocean industry thinking, meaning the borders between the different sectors, traditional sectors, is being toned down. So instead of being, as before, an oil and gas supplier company, more and more companies now see many other ocean industries as their market, which is good, of course, because it opened up a bigger market and growth possibilities, and it also helps secure the company's cash flow. OECD prognosis claims that the value creations from the oceans are expected to double from 2010 to 2030. And for a country like Norway, where the maritime and offshore industry represents 70% of our export values and more than 40% of our value creation, I mean, it's obviously important to take part of this growth. the last year, we have had a stepwise and very involving strategy process among about 80 of our member companies. And it took place last year through many, many workshops. And the conclusion here is specifically 3 areas are mostly important. So the first one, the autonomy, it really covers everything in the future industry digitalization themes. So it has to do with Internet of Things, sensors. It has to do with artificial intelligence, man-machine interfaces, and handling big data issues, and so forth. So that's the first one. The second one is the power transition and the power to X. And it covers the offshore renewable energy production and renewable energy storage. And also storage of then producing hydrogen from offshore wind and storing it subsea. And then again, transported either as transporting tanks or transported in pipelines for usage elsewhere. Now, the third and last area is the sharing economy and the circular economy. And that has to do, the circular economy has to do with both the economical part, but also the ecological part of sharing economy. So that's also a very important area moving forwards. Norway is an ocean nation. We live by and off the sea and has been doing that for centuries. So, and as I mentioned, I mean, like 70% of export income comes from the ocean industries. And there's none other countries even close to that in the world. So the ocean is our business. So of course we have to be a part of whatever happens in the ocean. And we have also a lot to contribute to the world development business in the oceans. So that's why it's important. Technology development is of course always a challenge, but it's also always solvable. So I think a bigger challenge is for us to mobilize as a nation. So we need political ambitions and courage to really point a new direction and follow up with specific and dedicated actions. And also governmental funding, because before we have all these green markets, we need to stimulate them to make the green ball rolling. And this stimulation can come from, well, has to come from the governments. A lot of people look upon the green shift as a sort of revolution. We should do everything totally different, but that's a challenge, and it's in a way I think a dream, because everything is an evolution, not a revolution in the industry. So we need to collaborate across disciplines and across industries to make this evolution speed up as fast as possible, because we're all in the same boat. We all want and need a more sustainable world, but there won't ever be any revolution. So to build a greener society, we need greener energy, we need greener transportation solutions, and we need greener food productions. And we do not have all the competence we need for the future, but what we lack and what we need, we will have to build on the shoulders of our existing offshore industry. That's the fastest way to become sustainable. So that's an important message, to reuse, repurpose everything we have learned, everything we have developed of technology, all the experience we have, and based on that, develop the new and greener industries and societies we need for the future.
So my name is Erik Dirk-Koren. I'm the CEO and co-founder of Seabus. Seabus is a spin-off from NTNU, and it rests on decades of research in autonomous technology and specifically marine autonomous systems. And we will commercialize small urban ferries running unmanned across rivers, lakes and canals in cities. Our technology consists of several parts. The autonomy consists of situational awareness software using sensor input, sensor fusion to create a picture of what's actually going on around our ferry. That situation is fed into a collision avoidance software, making sure that you don't bump into anything. And on top of that, we are actually also developing, together with DNV, a software for assuring that the whole system works trustfully. Because how can you trust a digital captain? That is a very important question. Cibus is innovating on many levels at the same time. We're creating a transportation system, so we need to put many pieces together. But the autonomy part is really what's, let's say, pushing the boundaries of what can be done here. Autonomous technology is really hot around the world, with cars, with ships, with planes, with trains, buses. So many things are happening. But we believe that autonomous technology will commercialize itself first on water before on the roads, because you have more margins of error. Things are slower, you have more room to maneuver. And that makes all the difference when trusting a commercial or autonomous system like this. NTNU has a prototype. It's sort of a one of a kind in the world of scaled down passenger ferry that can run across the canal here in Trondheim. And there's a second prototype NTNU is working on called Milliampere 2. All right. It's a full-scale model. It can take 12 passengers, and it will start test operation this summer. Cibus solves sort of three problems for three types of people. One is the citizens of cities. We create an easier way to move around cities for pedestrians and bikers by the shortcuts that are made across waterways that otherwise are blocking the transport. On the other side, we're city developers or property developers can use this as a means to make property areas more accessible from city centers or vice versa. So that could make more city-close urban development possible, because we can make those shortcuts as an alternative route in addition to the other main routes. Well, I think Norway is the perfect place to commercialize what we're doing for four different reasons. One is that we're in the middle of the center of gravity for competence in autonomous marine systems and technology at NTNU. We have authorities that are working closely with us to make rules and regulations on how to certify autonomous technology at sea. And typically the Norwegian Maritime Authority is looked at for developing rules and regulations for new technology at sea. So that really helps. Third, we have a long coastline with lots of needs of autonomous technology or ships and ferries that could really make this happen commercially. And lastly, I believe we have a population here that is used to adapt to new technology and can sort of accept this as a new way to travel. Cibus is more than a ferry company. Actually, we think that we're not a ferry company. We're a company working on solving major problems of future city development. So we're working closely with urban developers in smart city projects around the world to understand how we can actually make a difference and how our technology will affect cities in the future. And I think that's really the problem that we're attacking here. A lot of the typical roadblocks of startup life is moved out of the way because many of us have done this before. We know how to start companies. We know how to sort of get ourselves, or let's say, dress ourselves to be attractive, to get hold of even more good employees and also investors, which is like the most important part of a startup. How do you get the good people and how do you get the good investors to pay for that? And we managed both over the last, well, let's say 6 months. And it's when you have that starting point, the snowball starts rolling. And I think we're in the middle of a really good snowball run, if you will. We say 5 years from now, Cibus will have its first fully commercial product sold to a customer. Our initial thought that we're working on now is that it can be produced close to the customer. For instance, USA, it could be a very big market for us. They have the Jones Act, which means that boats that run along the coast needs to be produced in the US. Okay, maybe that's fine for us. So that's our mentality with that. The boat technology, making the boat, is not really core. What is core here to scale quickly, so that we have a design of the boat that can be easily made cheaply, quickly, and potentially anywhere that has a modern yard. So going forward, what Cibus really needs right now is more top talented people that in autonomy and also in business development, which is really important for us now. And we're building our ecosystem, shipyards and other companies that can help us build a system around our core technology. That's the most important part of our development right now.
My name is Geir Aksel Oftedal, and I am responsible for breakthrough innovation in Jotun's marine, protective and powder businesses. Basically, we're a paint maker. We make paint. We develop, manufacture and market paints and coatings for most types of surfaces. So we say that our sort of mission is to use paints and coatings to protect property. Biofouling is basically organisms attaching to the underwater hull of ships, starting out as individual cells, turning into slime, and then algae, and over time even calcareous fouling like barnacles and mussels. Biofouling on the underwater hull creates additional friction, and to overcome that friction, the ship needs to spend more energy. And spending that energy means fuel cost for the owner, and it means climate gas emissions that is negative for the environment. The IMO, this UN organization that regulate international shipping, they estimate that as much as 9% of the world fleet's total energy use is associated with overcoming the negative consequences of biofouling on the underwater hull. So coming up with good and definitive solutions to this problem is good for the environment, but also good for the industry in the sense of helping the industry save fuel cost.
My name is Bård Lunde. I am the operation manager for vessel robotics, the department in Kongsberg Maritime that is a part of the collaboration with Jotun on the hull skating solution. Kongsberg Maritime is a global company with about 7,300 employees. We are located in about 30 countries and have over 100 offices. So the hull skating solution is a solution combining coating and technology. It is an onboard solution for proactive cleaning on vessels, and it is remotely controlled. We have locations both in Norway and Korea and Singapore at the moment, and will extend that globally. It is operated with one guy then remotely and with assistance from the crew, and is a solution that is approximately 1 by 1 meter in size, and it has 4 magnetic wheels that will attach to the hull.
The idea here is to, instead of relying on paints with chemistry, either biocides or hull release properties by itself, we now combine chemistry with advanced subsea robotics that we call the hull skater, and do proactive cleaning, where basically we operate on the hull before the fouling has had a chance to become a problem, before it sort of reaches a maturity where it becomes a problem, either in terms of an increased need of energy, driving fuel cost and greenhouse gas emissions, but also before the underwater hull becomes a potential vector of what's called aquatic invasive species, where you bring one, call it the biology, from one ecosystem into another. That is increasingly also seen as a problem. So the whole proactive cleaning, just like brushing your teeth, don't wait until you have a problem. Be proactive and remove any sort of starting point for fouling before it comes to such a point that it causes problems.
The innovative part of this is that we are being able to proactive clean. And I think that is something that is not seen in the market before. It has something, I think it's been a request from the market for a long time, but there is no real solution that can handle it in this way. The experience Jotun has on fouling prediction is key to only use this solution when we need, and not just so blindly use it when we think we need. And that is a key to have an operation that is scalable and that actually can then apply the service at a cost-efficient level.
As our good partners in Kongsberg can attest to, breakthrough innovation involves a lot of challenges. And here, in particular, this hull skater, this advanced piece of subsea robotics, is to operate in an extremely challenging environment. And that's actually, that is a big challenge, but that's actually not the biggest challenge, because it's getting a reliable technology to work at a total cost of ownership and operation that fits the business case. That's the challenge. Getting the technology to work, if you don't care how much it costs, is not difficult. It's getting this technology, this concept reliable within what is needed to make it scalable. That is where the challenge has been. And fortunately, I think one of the things that we have done right is that we started with a business case. So we started with an idea of where we needed to end up in terms of cost. There's still some way to go, but we are definitely now heading in the right direction.
My name is Tone Berg, and I'm CTO in OSAK. OSAK is a company and a spin-off from SINTEF. And OSAK was founded in the late summer 2018. And me and another companion from SINTEF, we were the founders together with SINTEF TTO. And we started to work in the company in the autumn of 2018. Ghost fishing is a fishing gear that is lost or abandoned, and it's still fishing. And that happens because, for instance, a net is in the water column, and fishes are trapped in the net, and after a while the net perhaps gets very heavy, it sinks to the bottom, and then other fishes come and eat the trapped fish, and perhaps also crabs. And then it got lifted again, goes up again, and this is repeating itself. So it's called ghost fishing because there is, in fact, no human being that is, in a way, fishing with this gear. The most well-known form of ghost fishing is perhaps pots that are left or lost on the ocean. And then all lobsters, crabs goes into the pots, and they never get out again. And they can stay there for months, and it's not good fish welfare. In Norway, the recreational fishery loses 14,000 pots a year. Pygmy, that is the name of our system. And the aim of the system is to detect, identify, and position a gear. And the main purpose is to use it when it's lost. Because now there are about 640,000 tons of fishing gear that's lost in the ocean every year. That's a huge number. and we don't have any kinds of solution to find them again. So PingMe is a system that makes it possible for the fishermen to find them, but also makes it possible for other boats which have one part of the PingMe system on board to find lost gear. So that is because the PingMe is a system that consists of 3 parts. One is what we call the standalone or the transceiver part on the boat, which is kind of an echo sounder with a transducer on the bottom of the boat. That's one part. And then we have one part that's tagged to the gear, which is the transponder. This is the transponder. It might have a little different shape, but it's the transducer here, which receives the sounds. And then there is some electronics inside. And then the signal is reflected with this identity inside. And then you have this material around, and that is because of buoyancy, because it has to stand up by itself in the water column. So it's not like this. So then the system on board can see that, okay, this transponder belongs to Tone and not Elisha. And then also the system reports the findings up to a cloud system, which is the third part of the system. And this is because that if someone loses his or her equipment or gear, then he reports this to the cloud system. And if any boat there comes nearby and gets a reflection from this transponder saying, this is Tone, then and reports it to the cloud system, this is automatic. And so the position will then be also sent to the owner. It could also be used for alarming, for instance, pipelines from oil or from the windmills which are now coming. It could also be used for alarming coral reefs, which says that here you are not allowed to fish because you can destroy the coral reef. In many fisheries, both trawlers and fisheries which have pots, for instance, on the bottom, they fish in the same area, and then the trawlers can get the trawl into the pot, and then they take the weigh pot, and the fishermen don't find it. And now we are 7 persons, but we still need more on the, what should I say, hardware side and software side to develop the system. Yeah, and we also need some partners in the distribution system, like small companies that install and do all tests and corrections if the systems are wrong. PingMe is to be used in the ocean, and the ocean is in trouble because there is a lot of overfishing and there is a lot of debris, plastic. And this plastic, it comes mainly from the big rivers coming into the ocean, and we talk about 15 million tons every minute. And about 80% of this plastic comes from the rivers, while the rest comes from activities in the ocean. In the ocean, there has been a very, very little monitoring of what is happening and what people have done, and it's kinds of people, they don't care if they throw overboard a lot of things, but if you do that on land, it's very different.
My name is Jakob Grigeide. I'm from Norway, working in Scanridge. I'm responsible for the business development and scaling for Scanridge, also responsible for the communication and marketing. Scanridge was created in 2015 in order to solve the problem with connectivity in steel. And people ask, why do you need to have connectivity in steel? Well, you need, first of all, to connect to people. Today, it's impossible to connect to people if you don't have our technology on board, which means you don't know where they are. So if something happens, you don't get the help you need. What we do is extremely important. If you go back in time and look at what happened on land, wireless connectivity is actually one of the most important technologies to solve everything within safety, within all kind of use cases in order to smarten up the world, to decarbonize. A lot of the data you need, you can't cable to them because it's moving around or gases or whatever it is. So, but that technology used on land cannot be used on board a ship because you have steel. So you needed a new technology. And that's why it's so important that the ocean industries now can do the same. So when it comes to the applications for the technology and our solutions, we understood very early that we needed wireless connectivity and to make a ship safer, because you don't know where people are when things are happening. You have manual search and rescue and so forth. But when you have full connectivity in a vessel, which is needed to know where people are, you have a connectivity also to solve other applications. And that's, I think, the core here, that a lot of our clients are going with also other important applications like fuel monitoring in order to reduce fuel now before they become 100% renewable on the energy side. They need to reduce it. So then you need real-time monitoring of fuel flow, gases. So the applications now, which is coming throughout, the coming months, is fuel, environmental sensing, probably like vibrations, like when it comes to preventive maintenance. There is so many applications here. We can even track equipment, cargo.
My name is Espen Alexander Jørgensen. I'm a designer. I'm also a co-founder of Eggs Design and head of Ocean Space. Eggs Design is a design and innovation consultancy. We're about 120 people with offices here in Trondheim, in Oslo, Bergen, Stavanger, and also Copenhagen. So what we basically do is help our clients craft new products and services, and often also business transformation, which means that we help them do a bit more strategic work than what you usually associate with design. It's safe to say that when they contacted us, I kind of got the shivers, because I saw the potential of their technology, and I saw how we could, with our competence, bring value and help them accelerate that potential. Jacob in Scanreach has design background, so he knew what design could provide of value for Scanreach. Scanreach is more like a tech company, of course, and he saw that in order for them to have success, transformed their tech into viable, lovable, usable products and services. They needed design competence. But not just any design competence, they wanted to have design competence who knew the maritime industry. Because that's quite important, because there's quite many rules and regulations. It's quite complex, and this competence is something we in Eggs have loads of experience with.
I think the good thing with Eggs that we can work on the strategic, but also on the level where we need to produce something. So for us, they've been very important in the UX UI development of what's actually our clients is using on their daily basis.
When you start with technology, it kind of opens up, And how do you choose which market, which kind of application, who do you create value for? And often those unique technologies are it's not the technology in itself that you start selling. It's the technology in combination with other kind of technologies, services, etc., that builds up a whole thing, which you can call some kind of product or service or value proposition that you give to start selling some market. And the challenge there is that if you think that people are going to kind of understand the technology and appreciate the value of technology, you're wrong, I think. Because you need to package it. You need to kind of make it available, understandable, meaningful for the people that you want to cater for. So what they do is to start thinking in terms of, we need to involve the market, we need to involve the customers, we need to involve the users, which is a good starting point. That's of course where design thinking as well has its roots. But there is a pitfall here as well, because if you start just asking the market what they want, and especially if you have this kind of disruptive new technology, which opens up vast new kind of innovation space. If you start asking the market what they want, you don't get very visionary answers. You get small incremental answers, and you get, well, pretty fast user-driven or customer-driven. You become a kind of a slave to the market that you want to serve, and which market should you focus on. So I think this is where designers are good at kind of helping organizations to kind of use their eyes and ears to go out and understand the market, put it in kind of strategic context, but then try to come up with some ideas that you can then test out in the market. But it's not based on asking the market, it's based on inspired by people, how people work, live, etc.
If you look at the challenges ahead, I think the most important for us is that we scale, because we have used so much money and so much time, so we need to go positive. I think it's a lot of it when you develop deep tech like we have, and we come to the surface with a solution which is quite disruptive, there is a lot of skepticism in the industry. The regulation is not there helping you. The regulation, just by understanding that there is no regulation saying that you need to be found on board a vessel if something happens. That's like still driving the car without the seatbelt or airbag. I think you need much faster adoption of new rules and regulations. And I think the end clients need to come on board, and really say, I've heard about this new technology. We can set higher requirements to our sort of partners or ship owners that delivering services for us. And people are afraid of change. This is a very, I would say, a technology that will change a lot of things in the ocean industry. I think that's the main challenge we have. People are afraid of that. Companies are afraid of that.
Design for eggs is fairly wide. It's everything from strategic to craft. And I think the value that we provide with design lies within this kind of span from the strategic, knowing what to make and for what kind of reason. And last but not least, it gets focused. And what it gets focused on is people, the people who are going to actually, use this thing that we're trying to craft, because it's often overlooked or forgotten when you start working on these really complex systems. There's some people here. There's some humans ending up with the consequences of the work that we're doing. And it's our role to always kind of pinpoint this. But then we also need to kind of combine this with that things also have to be technically feasible, economically viable, it has to be sustainable, it has to be strategic, sound and fit with the kind of the business strategy or So balancing all these kind of needs, but always keeping in mind that we want to create something which is desirable and lovable for the end user. Because if it isn't, things will fail.
My name is Anders Ødegaard. I'm a senior project manager at SINTEF, and I've been there for 15 years. I'm in a group called Sustainable Energy Technologies. We work with solar energy, batteries and hydrogen, all kinds of green energy technologies. And my focus is on hydrogen, and it ranges from materials research up to demonstration and pilot plants. One of the projects I'm working on right now here in Norway, that's a project called U-boat, and translated it's submarine, but this time we're working above water, of course, and what we do there is to develop a hydrogen-powered service vessel for fish farming. And the intention is there to develop a fully new type of ship, and for that we also need the infrastructure to fuel the ship. So we're producing hydrogen close to the fish farm and refueling the hydrogen then on site. Hydrogen is a fuel which allows zero emission on a larger range of applications and also in industry. We have several projects at SINTEF which is involving hydrogen trucks. It's on trains. We're also looking into planes. And as I said, industrial use is also one option where we can contribute with decarbonizing to reduce CO2 emissions. Yeah, when you want to operate a ship on hydrogen, it's very similar to a battery electric ship. So we all know that there is electricity coming out of the battery, which powers the electric motor. In the same way, when you have hydrogen, you have a fuel cell converting hydrogen to electricity. So the whole propulsion system is the same. So you have an electric motor there as well. The difference is that you store hydrogen in a separate tank. So in the battery, you have the energy stored in the battery. In the hydrogen system, you have the hydrogen in the tank and the fuel converter in the fuel cell. So you create electricity from hydrogen and the air, and as an exhaust, you get water only. The innovative aspect of this project is that we need to reduce emissions from all kinds of sectors in Norway and globally as well. In Norway, fish farming is a large industry, and this type of vessels, for instance, they can emit 300 tons of CO2 per year. Along the coast of Norway, we have up to 1,000 of these linked to fish farms. So it means roughly 300,000 tons of CO2 per year. So this is something we have to change, and within the possibilities we have on technologies, we can go to zero emission by either batteries or hydrogen. So we know that battery technology can operate, for instance, many of our ferries, as we have seen now. But then again, there are some users who need to operate longer range or longer times. So these service vessels, they also, some of them operate between several areas. They can operate during a whole day, sort of going shifts. And then it will be difficulty to have batteries because you'll have to recharge. And that's also an aspect when it comes to these locations, which often are at the coast, where the grid can be a bit weak. So we do estimate that quite the part of the number of these the vessels, they'll have to be fueled by something else than batteries. For this project, the hydrogen will be produced locally from renewables, and it's done with electricity, so you split water into hydrogen and oxygen. The great advantage with doing this locally is that in fish farming you also need oxygen for fish growing and also feeding. So that's why we can exploit both values here, the hydrogen and the oxygen at once. Another byproduct of this production process is heat. So there's some efficiency losses in the process, and that can give sort of water at 60 to 80 degrees, which again can be used in the fish farming industry. So it's like 3-in-1 for these kinds of systems, and that's a big advantage. Access of hydrogen has always been a bottleneck for projects like these, because if you have some kind of application, a vehicle or a train or a vessel, you need hydrogen to fuel this fuel cell. And so far, you also need end users for the infrastructure. So the ones who want to sell hydrogen, they need to have the end user before they roll out the infrastructure. So it's a typical chicken and egg problem. Production equipment for hydrogen is small scale, is also not cheap. So the cost of the fuel will be relatively high. And that's why we are now looking into a larger rollout of hydrogen infrastructure. We need to have synergies between uses. So you have hydrogen trucks, you can have boats, you can have buses, and all of these can be refueled at the same stations, or at least they can source the hydrogen from the same production sites. We hope to get this ship out in the the sea already in 2023. So there's a year now where we're looking into technology development and design of both the vessel and the infrastructure. So partly what we do is to try and optimize the systems. So you can have a very adapted system. So the aim is to get the lowest possible costs for both the vessel and the infrastructure. And that's part of the major design question we have now. And when we have that in place, after a year, we need about a year to build the ship itself and also to construct the production facility. So hopefully at the end of 2022, we have all of this in place and we can roll the boat out into the water and do the first trials